The string of a simple pendulum is found to have a mass which is one-tenth that of the pendulum bob. The systematic error in the measurement of G due to neglecting the string mass is approximately. Following are the options. Before entering to the answer of this question, I just want to tell all the students that don't miss this video because this is an important question from the quotient physics. So if you search the answer to this question in internet, you will be only able to find only one answer to this question. That is provided by the toppers website. But the answer that they have provided is a precise version of this question's answer. So most of the students won't be able to understand the concepts really well. Some of them will skip that question. So I don't want the students to skip this question because it's an important question. And in this video, I'm going to clearly explain the answer to this question. Keep a pen and paper by your side so that you can solve this question along with me itself. So let's enter to the answer of this question. In this question, it is provided that a bob is attached to a string which is suspended from a height or suspended from a plane surface. So I'm considering the mass of this bob as mb and this string as ms. Now, in the question, we are asked that we have to find the systematic error of G, that is the gravitational constant. So, we have to find the systematic error of G as well as it is given. We have to find its error by avoiding the mass of the string. That's an important thing. Note down that in the question itself, it is provided you don't need to consider the mass of string. So we have to find the systematic error. We have learned the equation for tension, that is P equals 2 pi root L by G, right? So from here we have to find this value, so we have to write this equation in terms of G first of all. For that, I am squaring on both sides of this equation. Thus, we get P square equal to 2 pi, that's 4 pi square into L by G. Now, taking this G to the other side and P square to the right side, we get G equals 4 pi square into L by T square. Since it is a constant, we don't need to consider this one. So using this equation, we can write the equation for the systematic error. We have learned that the equation for systematic error of G is delta G by G, which will be equal to, since there are two terms given other than constant, that is L and T, we can write it as delta L by L, since G is proportional to L, and T square can be written as square. We are writing here, that is 2 into delta T by T. So I'm not taking this T value since in the question itself we are given that the mass of the string is avoided. So if there is no mass of the string, then there will be no string. So there will be no tension also. So the tension get cancelled. So the remaining term is this one. We have to find this value. For that, first of all, we should know this value. Here I am taking the length of the string as L. So this is the length of the string. Okay. So I'm considering the center of mass is situated here. Okay. So let me get this. So the center of mass is here, and I'm considering the distance from the center of mass to the top surface of the system as L dash. So we can write here delta L as L minus L dash. So this L minus L dash will give this value, this length. That is, I am giving it the name as x. So this distance is x, this small distance is x, and so now we have to find this value of x. This is equal to x. Then only we will be getting the value of delta n. So consider that the system is placed in a horizontal way like this. So this is the M S and here is the M B. Here I have plotted this MS, that is this point, in such a way that we are getting this distance approximately equal to L by 2. In that manner only you need to plot this point MS. So we get, here is the center of mass, and this distance we have named it as x, and this will be, this distance is L by 2. So we have learned an equation that is ms, that is this mass, multiplied with the distance between the center of mass and this mass ms is L by 2, which is equal to mb, which is the mass of the pendulum bob. This is mb into the distance between the center of mass and this mass of bob, which is x. So from this equation we have to find the value of x. So we can rewrite this equation as x will be equal to ms by mb into L by 2. So we get the x value is equal to ms by mb into L by 2. So in the question it is provided that the ms, the mass of the string, is 1 by 10th the mass of bob. It is given in the question. So on giving the value for ms as 1 by 10 into mb, we get x equal to mb by 10 whole divided by mb into L by 2, which we get the answer as, here mb and mb get cancelled and the remaining is 1 by 10 into L by 2. So we get the answer as L by 20, which is equal to x. So since it's given that delta L is equal to L by 20, we get this value, that is, which implies delta L. I'm taking this L to the other side, hence we get delta L by L equal to 1 by 20. So we can write the value of delta G by G, that is equal to delta L by L, which is 1 by 20. Here in the option, it's given that all the provided options are in percentage form. So we have to convert this term into percentage form. For that we need to multiply it with 100. So we get 1 by 20 into 100. This 0, 0 cancelled. Then the answer we get is 5. So the answer is 5%. This is the correct answer.
If you like this video, do subscribe and click the bell button.